Welcome to section 4.1, and what we have going on here, the beginning of a new chapter, this is dealing with applications of derivatives. Now we've already looked at many of the applications, and so some of these sections are going to be repeats. It's just we're going to involve such things as the chain rule, the product rule, the quotient rule, and implicit differentiation in order to get to our answers. But we do begin with what are called critical points, and that's what we're dealing with here at first. And critical points tell us several things. It will tell us maximums and minimums, but we need to get some terminology going on here. And so we're going to take a look at number one. And number one looks something similar to this, where this is A and this is B. That may not be quite as obvious as what it should be. And we are asked, looking at this graph, I'm looking for absolute extreme values. Now absolute means there's nothing on the entire graph, at least within the interval A to B. There's nothing in here that will be higher or lower. And so we look, hopefully it's very obvious that we do have an absolute maximum. This is the absolute highest point that this graph shows up in between the interval of A and B. So this is the exact, or the absolute highest. But now we look at this. Since this is open, then that means there can't be any particular absolute minimum here because there's no end. I mean, we know it's a certain value, but we never get there. Okay? Likewise, here down at B, we're reaching a certain minimum, but we don't know what that value could be. So as a result, there's the absolute maximum right here. There's an absolute max, or an absolute maximum here, but we can't determine with any certainty the minimum that would occur here or the minimum that would occur here. And so out of those four choices, D is the only choice we have. There is an absolute maximum only. Now 2 and 3 asks us to find the absolute extremes here, and it's on the interval that is shown. Now absolute means the absolute biggest or the absolute smallest, and nothing can go bigger. So we look at number 2. We notice that it starts at -5 and it ends at +5. And between those two intervals, or those two values, we are looking for the maximum. What is the absolute maximum that occurs? Well, it occurs at the point 0, 4. And so the maximum would be 0, 4. Now there are some absolute minimums also. The minimum would be -3, 0, and 3, 0. Those are absolute maximums. And then those would be absolute minimums. And then we have what are called relative maximums because they're a high point for a certain part of the graph, and that would be at -5, 3, and 5, 3. And notice they're not absolute maximum because the 4 was actually bigger. And so we only have the one maximum. I'm just going through all the other possibilities that we could have. Number 3, we're looking for an absolute minimum. Now I look on that graph, I do see a minimum and I do see a maximum. I see the minimum when it comes down here like this and goes back up. This is a minimum. The problem is it's not the absolute minimum because a little bit later on it goes further down south and it goes forever. So this would be called a relative minimum, and that relative minimum appears to occur at 1, -2. There also appears to be a maximum of sorts, but this would be a relative maximum, not an absolute. So, and the relative maximum would occur at -1, 2. But the point remains, is there an absolute minimum? No, there are none. There are no absolute minimums for this particular problem. Okay, continuing, the next group, the answers look ominous, but really it's just a matter of breaking it down and seeing what we get here. Now, if we look specifically at the table, we are given certain values of x, and we're given certain values of f prime of x. Okay? And we are given 3 points, A, B, and C. They're not very particular numbers, but we need to remember that f prime represents the slope. Now, if we look at A is the point where it goes from here to there. Now, the slope coming from this direction appears to be like about that steep, and from this direction appears to be that, almost perpendicular or normal to it. So, since depending on which way we come determines which slope it is, we have to say this does not exist. The derivative does not exist right there, mainly because that's a point. Remember, it's differentiable if it doesn't have a point, and if it's smooth and continuous, it's continuous, but it certainly is not smooth here. Okay, then at B, we have this point that comes right here. Now, the derivative would be the slope of the line right at that point. Well, to me, that appears to be a horizontal line, which means the slope would be 0. So right now, we're down to either B or C. And then finally, here at C, and I realize the graph doesn't look very much like what was on there, but here at C, it appears that the slope is like -1 right at that point. It certainly isn't positive 1, which is option B. So the only one that says does not exist and 0 and -1 in that order is option number C. Now, how do we find the extreme values? The extreme values occur where the derivative equals 0 or where the derivative is undefined. Okay? So those are the two things. If the derivative is undefined, it's a critical point. Okay? And if derivative equals 0, that's a critical point. If the derivative is undefined, it's a critical point. And maximums and minimums will occur only in those critical points. Okay? So let's look at number 5. Number 5, we have f of theta equals the sine of theta plus pi over 2. And we are given additional information that's basically telling us we're only interested between 0 and 7 pi over 4. And so if we would look at a graph of this very quickly, we know that sine of 0 is 0, but when we plug in 0 in for theta, we are actually finding the sine of pi over 2, which is at 1. So it's going to go to 1, down like this, down to -1. So there's +1 and -1. This is at 0. This would be at pi over 2, because pi over 2 plus pi over 2 becomes pi. Then this would become pi. And then we start coming back up, and where it would cross again would be at 3 pi over 2. And we are way beyond 7 pi over 4 now. Oh, no, not quite. And then we have to go up just a little bit more for 7 pi over 4, which will be another pi over 4 here. Okay, so this is the graph. Now we can tell it appears like we've got a maximum here, an absolute maximum. It appears we have an absolute minimum here, and there appears to be a relative maximum there. Now, I told you a little bit wrong. We need to not only test the critical points, but we also need to test the endpoints. The endpoints might be absolute values as well. So let's keep that in mind. So I'm actually going to plug in f of 0. F of 0 would be the sine of 0 plus pi over 2, which is the sine of pi over 2, which equals 1. And remember, we think that's the maximum, but we'll see. The other endpoint would be 7 pi over 4. equals the sine of 7 pi over 4 plus pi over 2. And this is equal to the sine of, what, 9 pi over 4? Which is equal to root 2 over 2. Because the reference angle would be pi over 4 in the first quadrant. And the first quadrant means it's positive, and the sine of pi over 4 is root 2 over 2. So, and it doesn't take much to realize root 2 over 2 is less than 1. So this is actually more of a maximum than this. But looking at the graph, this is a maximum of some sort, or at least it certainly appears that way. Then finally what we need to do is we need to take the derivative of this and find where is that undefined and where does it equal 0. And that will tell us what goes on here. Now we better end up with pi, but we're going to check and see, okay? So, going to take f prime of theta will equal, okay, this is, I'm going to have to use the chain rule. The sine of this would be, or the derivative of the sine of that would be the cosine of that times the derivative of this inside part. The derivative here is just 1, so that makes life a little easier. So I ask myself, this equals the cosine of theta plus pi over 2. I ask myself, where is this undefined? Well, it's defined everywhere, so there's no critical points because of that. But I do need to set this equal to the cosine of theta plus pi over 2. I need to set that equal to 0 and see what I get here. Well, I look at theta plus pi over 2. Where does the cosine equal 0? Well, the cosine equals 0 at pi over 2. It also equals 0 at 3 pi over 2. And it also equals 0 at 5 pi over 2. And it just goes on, 7 pi over 2. And I just need to figure out, how much further do I have to go? Well, each time I'm going to subtract pi over 2 from each one of these. So that means theta would equal 0. Or it would be at 3 pi over 2 minus pi over 2, which would be pi. Or it would be 5 pi over 2 minus pi over 2, which is 2 pi, but that we're already outside of our range. Remember, our range only went to 7 pi over 4. So the only places where we should have critical points are at 0 and at pi. Let's go back up. Our graph, and look there. At 0, we appear to have a critical point, a maximum in this case, and at pi, we have another critical point. This time it appears to be a minimum. And so we can determine right at those points, we know that f of 0 we've already determined is one of our points, so that was the point, 0, 1. And at pi, if we plug in pi into f of pi is equal to the sine of pi plus pi over 2, which is equal to sine of 3 pi over 2, and the sine of 3 pi over 2 equals -1. And so we have another critical point, pi equals -1. So we've already determined by looking at the graph that this is an absolute maximum, and this right here is an absolute minimum. Number 6. Number 6, we have h of x equals 2/3 x plus 4. And we're only interested between -2 and 3. Now this shouldn't be too difficult to graph because this is actually a linear equation. We're interested between -2 and 3, so I'm just going to find those points and draw a straight line. -2 would be -4/3 plus 4, which is what, 12 thirds, so that'd be 8 thirds, which is 2 2/3. And 3, if I plug in there, I would get 6. So there's my real exciting graph, like that. Now, first thing, I'm going to take the derivative and find the critical points. Well, the derivative of 2/3 x plus 4 is simple 2/3. Big whoop. You know, because mainly, when does this equal 0? Never. When does it, when is this ever undefined? Never. And so, what we get going on here is the fact that this is pretty boring. The only thing we have to worry about are the endpoints. So this endpoint, in other words, h of -2, is equal to 2/3 times -2 plus 4, which equals -4/3 plus 4, which equals 8/3. And the other endpoint was 3. h of 3 equals 2/3 times 3 plus 4, which equals 2 plus 4, or 6. And so we have one extreme is going to occur at -2 8/3, and the other extreme is going to occur at 3 6. Simply by looking at the graph, we see that this is the absolute minimum, and this is the absolute maximum, because nowhere in that interval will there be anything bigger than this, and nothing will be smaller than this. Going on. Number 7 asks us to find the absolute extreme value of the function on the interval. And basically it's the same type of problem that we've been dealing with here. And we're given between -1 and 27. So the first thing we need to do, really, we would want some sort of a graph. But, well, let's just take the extremes. F of -1. Let's see what that gives us. F of -1 is equal to -1 raised to the 2/3 power, so that would be -1 is squared, so that's 1, and the cube root of 1 is 1. Well, that's real exciting, the point -1, 1. And the other extreme would be 27, and so that's 27 to the 2/3 power. Now here I'm going to actually take the cube root first. Cube root of 27 is 3, and then square that. 3 squared is 9. And so we get the point 27, 9. Now it's obvious that this one's a little bit bigger than this one. This one may be minimum, may be maximum, whatever. But what we need to do now is we need to find the derivative. So f prime of x is equal to, okay, take 2/3 times x to the -1/3 power. So this would equal 2 over 3 cube root of x. When we take care of the negative puts it down in the denominator, the 1/3 makes it the cube root. And we need to ask, where does this equal 0? Well, regardless of how hard we try, this never equals 0. However, there is a time when this whole thing would be undefined, and that is when the denominator, 3 cube root of 3 equals of x equals 0. Whenever the denominator equals 0, there's a critical value potentially there as well. So when we solve this, we divide both sides by 3 and cube both sides so that x still equals 0. So we have another critical point. We've found the endpoints already, and then we plug in the 0. Very quickly, f of 0 would be 0 to the 2/3 power, which equals 0. And so we get 0, 0 is critical point. This is a potential point, and this is a potential point. And we're looking for the extreme values. The only extreme values will occur at the endpoints or at the critical points. And the critical point here was just 0. So I look, which one is the absolute biggest? It's this one, 27, 9. So this is my absolute maximum. Which one gives the smallest y value? It's this one right here. So this would be the minimum, the absolute minimum on that interval, because that's the only critical point there. Okay, so this is without having to do the graph. You can determine these. First of all, take the endpoints, and then secondly, find all the critical points. The critical points, whenever you find those critical points, it's where the derivative equals 0 or where the derivative is undefined. Either one of those two situations occurs. With that in mind, let's look at number 8. Number 8, we have, it just says find all the critical points. We don't really need to find if it's a maximum or a minimum, but we're asked what are the critical points. And f of x is equal to x cubed minus 3x squared plus 8. So I need to take the derivative to find the critical points. So the derivative would be 3x squared minus 6x. And I look, is there any place that that's undefined? No, it's defined everywhere. However, it will equal 0 at certain points. And so I'm going to set that equal to 0. Factor out x, and I get 3x. Actually, I want to factor out 3x. And that would give me x minus 2 as the other factor. And so 3x equals 0, or x equals 0. And x minus 2 equals 0, or x equals 2. And so there we have the x values for each of our critical points. And so then we need to figure out what is f of 0 and what is f of 2. F of 0 would be 0 cubed minus 3 times 0 squared plus 8, or this all equals 8. And f of 2 would be 2 cubed minus 3 times 2 squared plus 8, which equals 8 minus 12 plus 8, which equals 4. So our critical points would be 0, 8, or 2, 4, just achieved from there. And that's all that we're asked to do. Find the critical points. We found them. We're ready to go. Example number 9, same directions, different problem. Number 9, we have y equals the quantity x plus 1 raised to the 2/3 power. Okay, this is a chain rule, but it's a pretty simple chain rule. When we take the derivative, y prime equals, okay, bring the exponent out front, leave the inside alone, and subtract 1 from the exponent. And then take the derivative of the inside and multiply it. Well, the derivative of the inside is 1, so it's times 1, so that's okay. Just cleaning this up, I get 3 times the cubed root of x plus 1, all under 2, like that. So that's what the derivative is. I ask myself, where does this equal 0? Well, regardless of how hard I try, since this never equals 0, the whole thing will never equal 0. Where is it undefined? It's undefined where this equals 0. So I need to figure out where is 3 cubed root of x plus 1 equal to 0. Divide both sides by 3. Cube both sides, so x plus 1 will equal 0. And then subtract 1 from both sides so that x equals negative 1. And then, am I doing the wrong problem? Yeah, I'm doing number 11, ain't I? Well, guess what? I'm going to skip and do number 11, which is what I'm doing right now. I was beginning to wonder. Number 11 asks us to find the extreme values on the function and where they occur. Okay, so I've done really the hard part. I need to plug into the y equation, I need to plug in negative 1, and so that gives me negative 1 plus 1 raised to the 2/3 power, which is 0 to the 2/3 power, which equals 0. So my point would be negative 1, 0, and that is an extreme value there. And what we would do is we would look at a graph and we would determine that this is indeed a minimum at -1, 0. Now there is another way to determine whether it's a maximum or a minimum. We're not quite ready for that, but we will get to it before the end of this chapter. It's called the second derivative test. Right now, we're just dealing with critical points though. So that was number 11. Now, if I can put my head back on straight, I can now go back to number 9. And yes, that was the first mistake of the year. So we have y equals 2x squared minus 64, the square root of x. Now the first thing I'm going to do is I'm going to rewrite this into a user-friendly form. So 2x squared minus 64 times x to the 1/2 power. I'm going to take the derivative of that. So the derivative would be 4x, and then 1/2 times 64 is 32, x to the -1/2, and rewriting this into a more acceptable form, 4x minus 32 over the square root of x. Now this could be argued this is just as unacceptable as that, but you know what, in this class this is perfectly fine. Now we need to determine all the critical points. So the first place I need to do is, where does this equal 0? And it is possible that this might equal 0 someplace. So I'm going to multiply everything through by the square root of x. So if I multiply everything through by the square root of x, I get 4x to the 3/2, because it's x times x to the 1/2, minus 32 equals 0. Add 32 to both sides. Continuing over here, divide through everything by 4, so x to the 3/2 equals 8. And if I take both of these to the 2/3 power, this becomes x, and 8 to the 2/3 power equals 4, because the cube root of 8 is 2, and 2 squared is 4. So I get 4 as one of my critical points. So I need to figure out, okay, at 4, what would I get? Well, I'd get 2 times 4 squared minus 64 times the square root of 4, or 2 times 16 minus 64 times 2, or 32 minus 128, which equals a -96. So one of my critical points is 4, -96. Now that's when the derivative equals 0. But I also have to ask, where is it undefined? Because that is also a critical point. Now the only thing I have to worry about is this right here. The only place this is undefined is right at 0. I mean, it's actually undefined when x is negative, which would possibly cause a problem here. But the thing we have to worry about is when x equals 0. That's pretty simple, you know. Square root of x can't equal 0, so that means x can't equal 0. So there's another critical point. And so what I need to do is I need to plug 0 into y and see what we get. So to finish this up, I'm going to plug in y into 0, or 0 into y, and get 2 times 0 squared minus 32, no, minus 64 square root of 0. And so that would be 0 minus 0, or 0. So the other critical point is 0, 0. So my two critical points are 4, -96, and 0, 0. And that takes me through 9. And I'm going to finish this video with problem number 10, which will actually take us through 11, since I've already done 11 accidentally. So, number 10. We are asked to find the extreme values and where they occur. So, number 10, y equals x cubed minus 12x plus 2. There's no restriction on the intervals, so we don't need to worry about the endpoints, but we do need to worry about the derivative, our critical points. So the derivative would be 3x squared minus 12. Where is this undefined? Nowhere. It's defined everywhere, so we don't need to worry about that. But I do need to set that equal to 0 and find out where that is equal to 0. So 3x squared will equal 12. X squared, when I divide by 3, equals 4, and so x will equal either the positive 2 or the negative 2. And what I need to do is I need to plug in both of those values into y. So if I plug in 2 in for y, I get 2 cubed minus 12 times 2 plus 2 is equal to 8 minus 24 plus 2, which equals negative 14. So 1 point would be 2, negative 14. And that looks good. And then y negative 2 would equal, okay, this would be negative 2 cubed minus 12 times negative 2 plus 2, which equals negative 8 plus 24 plus 2, which equals 18. So we get negative 2, 18. Now, one of these has to be a minimum, one has to be a maximum, because one is definitely higher than the other. So this would be a minimum, since it falls lower, and this is a maximum. And just a little bit of thinking should tell us, you know, is this an absolute minimum or an absolute maximum or relative ones? Well, x cubed, remember, always has this shape, or it might have this shape. But the point is, there's no absolute maximum, there's no absolute minimum. So these would have to be relative minimums and relative maxima. And like I said, finished for this video. The next video is very short. There are only 3 problems that we're going to do, but I'm just out of time right now, and I won't have time to get back to it. So the next video is coming up. We'll finish those 3 videos, and we'll go at it.